there's this narrative of like, LLMs replacing jobs, replacing programmers in particular, especially in terms of like FreeCodeCamp students. I would say like, even if you want to get into AI, there's always a value in, having good software fundamentals, software engineering fundamentals, programming fundamentals, really understanding like the foundations of AI, which include things like probability and statistics.
I have a picture pinned to my wall, an image of you and of me, and we're laughing, we're loving it all. But look at our life now, all tattered and torn. We fuss and we fight and delight in the tears that we cry until dawn. Hold me now. Whoa. Welcome back to the FreeCodeCamp podcast. I'm Quincy Larson, teacher and founder of freeCodeCamp.org. Each week we're bringing you insight from developers, founders, and ambitious people getting into tech. And this week we're talking with Yifan Mai, a senior software engineer on Google's TensorFlow team who left the private sector behind to go do AI research at Stanford. Yifan is currently lead maintainer of the open source HELM project, where he benchmarks the performance of large language models. Yifan, welcome to the show.
Thanks so much for having me, Quincy. It's an honor to be here.
Yeah, and I'm hyped to have you here because you have the benefit of having worked in the private sector as a software engineer and now also as a researcher at Stanford. So you've worked, as doing like hardcore software engineering on Google's TensorFlow team, and now you're doing like hardcore cutting edge research with these emerging models and figuring out how good they actually are. And that's like super duper exciting to me.
Yeah, I'm really glad to be talking about this stuff.
Yeah, and I'll just give the audience some perspective on how you and I met. So I went to this event in Singapore, or it wasn't in Singapore, but it might as well have been. There was like tons of Singaporeans in San Francisco. And of course, you grew up in Singapore?
Yes, I grew up in Singapore. I moved here in 2010. So I've been in the Bay Area, San Francisco Bay Area for about 14 years now.
Yeah. Yeah, and you've really made like good use of time. Did you come over as an international student, or how did you get here?
Yeah, so I was originally, so I grew up in Singapore. I did most of my schooling in Singapore. I moved here for university, so I did my undergrad at Stanford, and that's when I came here. And I stayed here. I basically stayed on after that and kept working here, and that's where. And then I did my undergrad and master's at Stanford, and now I'm working at Stanford. I like to joke it's a bit like moving back into your parents' house.
Yeah.
But it's like I really enjoy being in the Bay Area.
And is it common for someone to just leave? Because I mean, people leave academia all the time for the high-paying, like fancy, jobs, cushy jobs in Silicon Valley, in New York City, places like that. But is it common for someone to leave that life behind voluntarily, just like sit down their tools and go, basically do something almost completely different? Doing research is very different from applying tools, or maybe you were doing a lot of research while you were at Google, in addition to being a software engineer. But like, is that kind of a common career progression, or would you say that's relatively uncommon?
Yeah, good question. I'd say it's quite different because like the academia track in particular. So I have friends who have transitioned in both directions. So I have friends who did a PhD in academia, and part of PhD is doing research and then coming back to engineering in industry. And I also have friends that have done engineering in industry and decide like, oh, I want to go and do research and go back to academia and do a PhD. And now some of my friends are faculty members, formerly industry and now they're faculty. I think the sort of like the motivations for doing that, there's like both like academia and engineering industry are very different career paths with very different incentives. In the US, especially, like academia is kind of a rigid track where you're expected to you have a very fixed career path where you're expected to do a PhD and then possibly a postdoc in between. And then, you have a junior faculty and a senior faculty. And it's a little like it's sort of different from academia, from industry. And for my friends who've done it, like they moved from engineering back into academia, I think a lot of the motivation is they wanted to do research, like they wanted to really like advance a certain field. For me, the motivations was a little different because like I'm sort of different from my friends in that I didn't actually go back to academia to do the academic track. So I do not have a PhD and I'm not
Yeah.
planning to do a PhD, which is like very unusual. I'm basically
So
like,
wait, did you
yeah,
you don't have any intention of doing a PhD?
I don't, which is like I'm literally the only person in my lab who's not like thinking about getting a PhD or already has a PhD. Um,
Is,
I sort of think of myself more of like an engineer because like I like building things. So that's sort of a little different from from like what my friends' motivations are because like I'm not gonna be on faculty track ever, basically. So I'm not gonna be a professor. And the way I'm thinking about it is like instead of like my impact being publishing research, like leading research. I'm thinking more of my impact as being a supporter of scientific researchers. So I write software, open source software, and I maintain infrastructure that enables other scientific researchers to do their stuff. And I think that's all like a big motivation for me. I think like I really enjoyed being close to researchers. Like at Google, I also had a bit of that because I worked on TensorFlow and their machine learning researchers in Google who use TensorFlow for scientific research. But my current role, like I feel a lot more closer to the research that I'm advancing than when I was at Google.
that's interesting. It's almost kind of like a data engineer role where, like the way I think of data engineers is they're teeing up the data for the data scientists, right?
Exactly.
They're absolutely essential in getting the data scientists what they need to do their job, but the actual job is done by the like maybe a weird analogy, but like the pilot flying the plane that's dropping the the paratroopers in during trying to reclaim the country from the Germans or something like that, right? Like you're actually kind of like putting them in position so that they can succeed in their mission.
Mm-hmm.
But your skill set and the work you do is a little bit different. And of course,
Yes.
your background is different, and your goals, as you said, the incentives are different because you're not trying to become like a tenure track, professor at some big research institution. You're already at a big research institution, but you're doing kind of like a more kind of like a dirty job of like mucking around with the actual data and the actual software.
Mm-hmm.
Would that be
Yeah,
an accurate description?
I think that's exactly right. Like that's how I think a lot about like so when I was at Google, I was working on TensorFlow and a project called TensorFlow Extended as in particular that's like building machine learning infrastructure. And researchers would research a lot of research is done on TensorFlow. So TensorFlow is like a machine learning framework, right, for building models. And a lot of research, like machine learning research, is done on that. And I sort of see my job as like working. Like, I really enjoy working on infrastructure. I like building things for other people to use. And sort of like my transition is kind of like instead of building things for industry to use, I'm building things for academic researchers to use and other open source users as well, not just people at Stanford. So I kind of like, I really enjoy being this kind of like, build things for research users because they have lots of like interesting ideas and enabling them and like enabling those ideas and like really talking to them and like learning their use cases. That's like really fun and enjoyable. And like I sort of discovered that I really like doing that. And I also do believe like in industry, there's tons of smart people doing this stuff. So my current job role is my job position is called research engineer, or in some other universities we call it research software engineer. So
Mm-hmm.
these are essentially programmers who help researchers accomplish research, right? Either by building infrastructure, building software, sort of applying the practice of software engineering do research, because like researchers themselves might not be software engineers. They might not be aware of like the best practices of engineering, even basic stuff like, how do you build production systems? How do you build, how do you use code control? How do you do monitoring? These kinds of, this skill set is sort of like things that are familiar to engineers, but not just familiar to researchers. And there's sort of like a lack of good engineering, I think, in the research context. And in some cases, like it can really accelerate. I think research can really be accelerated, if more software engineers just were on this track and like really, wanted to be in this role.
Can you give me some concrete examples, like maybe like something you've noticed where like, oh, researchers have been doing this, but like in industry for years we've been doing this superior thing, and now I'm like kind of bringing this fire down from the gods to the researchers so that they could, cook their chicken more effectively, so to speak.
Yeah, I mean, I have some really incredibly basic examples that you
Sure.
might actually find like laughably basic. But one example is when I first joined this organization, they were sort of like getting ready to push out this initial paper for HELM, Holistic Evaluation of Language Models. And they were trying to essentially, like, they had a front end that visualized, the results of benchmarks run on models. They had this UI that showed, here are all the scores that the models get, here are the requests we sent to the models and the responses from those models. When I looked at it, they were literally loading hundreds of megabytes of JSON files into the Chrome browser, into your web browser per page load, and it was crashing the browser. And I was like,
wow, they were doing this. Why were they doing this through a browser?
Yeah, because they were building the UI for viewing the results it was a web app, right, for viewing the results.
Oh, okay. So this was like rendering the results.
Yeah, it's rendering the results, but they didn't do any form of like filtering or pagination. So they were just like rendering these giant web pages that that like would make a call to fetch hundreds of JSON files and then render this massive HTML DOM tree that would just like eat up all your memory and crash your browser. And I was like,
so
this is just like basic,
very basic web development fundamentals.
Yeah, so very basic web development stuff. Like further on in the life cycle of this project, we had a few volunteers. We actually had a volunteer from outside Stanford help us port things to React, and that made like everything work so much better. Like the web app was so much faster. It was so much easier to maintain. So this was like, I'm not gonna claim credit for it. Like it helped out a bit, but this was mostly one of my master's students, Farzan, and an external contributor who helped work on that.
Yeah.
Yeah.
So essentially, just taking kind of like a lot of fundamental, know-how that you've built up working at, you worked at Coursera, you worked at Google, you've worked at like a lot of big tech companies in Silicon Valley with like lots of best practices and kind of like a lot of methodology and like their like code smells and things like that you probably picked up, and one of them might be not having pagination and loading too much into the browser. So you were able to kind of like, there was a lot of proverbial low-hanging fruit that you could grab that was just accessible, but people didn't know to reach up and grab it.
Yeah, I think more like maybe less trivial or less trivial examples. For instance, things like how do you do continuous integration, right? How do you test code and make it, keep it working while you change it. Things like what technologies do you use? Like my colleague at Stanford, David Hall, also research engineer, he used the Ray framework for this distributed data pre-processing for machine learning models. So there's like, you have a problem, what kind of technologies are appropriate? Things like, things like, I mean, a lot of these are like sort of code practices, like even things like Python packaging, right? Making your code so that you can install it from pip. Like that's something a lot of researchers like don't bother doing because it's um, tricky. Also, a lot of this, like some of this work, I would say that like some of this work has to do with incentive alignment as well, because as a researcher, your job is sort of to put out papers because that's what you're measured by, right? And it's not necessarily to put out good software. So if you look at the code that's written like for papers, they might not be easily usable by another person. So another researcher externally might look at your code and they might take hours to get it to work, or they might have to re-implement it
Yeah.
themselves. It might not be a pip install, like Python pip install sort of situation. Yeah. And in many cases, like the researchers, they do know how to do it, but they don't have the time to because they're busy writing papers. And like creating, easy to use software is not part of the incentive structure.
Yeah, I mean, if all you're measuring is the research output, and you're not measuring the hidden cost of people who are trying to reproduce your work, having to like deal with spaghetti code bases and stuff like that, and get things running, then like, hey, my job here is done, and you walk away from this rigmarole mousetrap game thing, and yes, you've got some additional citations, and the department chair is happy with you, and you're going to be able to hopefully secure funds for more research and all that, like that. Those incentives that researchers face. And I don't have any experience doing research. My H number is extremely low. I do have a Google Scholar account, but it's like just a few people have like cited like some of the stuff I've done, but none of it was approached as a researcher. It was just me trying to put public information out in the public. But maybe you can describe the incentives that they face, or like obviously you have a lot of peers that are researchers. You work with these people every day. Obviously Stanford is a very prestigious place, but you can imagine a lot of research institutions that are not name brand household names. What are some of the priorities of a typical researcher, and how would they differ from, a software engineer who's trying to write, maintainable code that'll run reliably and things like that?
Yeah, so I work with a lot of PhD students and a few postdocs and faculty. A lot of what people are measured by is the impact of your research. And impact is sort of very vaguely defined, right? I like to joke that researchers are the original influencers because you're sort of measured by how many people like know of your work or are familiar with your name. And like a lot of researchers are just on Twitter now, or X, I guess it's called. But like literally this course happens on Twitter, and I've seen people literally put screenshots of tweets in their research talks. But the way you measure impact and influence is also a little ambiguous and depends on a specific field. So I was mentioning earlier, like software artifacts, most researchers don't really care about that. I should clarify that it does depend a little bit on the field, because like I see, for instance, in AI, I have seen some researchers say, okay, I've written a software package and it has like 10,000 stars on GitHub, and like, big tech companies are using it. And that's sort of their measure of impact, right? Like people are using my work because they're using my software. So that's sort of like, I think there's sort of a shift in culture, especially in the AI field, where like, if you write software that's being used, that's also considered impact. But that's not necessarily true of other fields. Like there are some fields that, that's not true. And even within AI, in the quality of research software sort of varies a lot. Some packages you can just pip install and they're easy to use. Some of them, it's research spaghetti code that works, but it's not really usable to another user. So it still varies very widely.
Well, let's talk about HELM, because that's the project that you are the lead maintainer of, I believe. And if I can like kind of express what this project does, essentially you try to take all these different models out there, like GPT-4, Claude, like all these other large language models, and essentially you evaluate them to see how strong they really are. And I'm really interested in how you measure how good something, like there's so many different ways. There's standard exams. You can give it the bar exam. You can give it probably like there's like an established corpus of like paces that you put it through, and you have to come up with like standard metrics that you can apply, and then you have to like grade these. And this, I'm not sure how impactful Helm is in terms of like, you know, a lot of these models, they're marketing like their performance on different benchmarks, and they're marketing like just the overall power of their model, right? And especially with like models that are like sized differently, like Google has like, I think like 3 or 4 different sizes of Gemini, and Facebook has like maybe different versions of Llama that they've put out there. And so you have to be able to make like apples to apples comparisons for like different tiers of, you know, models based on like how many parameters they are, or what kind of hardware they can run on. Maybe you can talk about that. Like, I'm just throwing a bunch of stuff. And please note that like I know nothing about what I'm talking about. I'm just trying to structure a question and tee it up for you, Yifan, so you can like I guess my question is, what do you do?
No, that's actually a really great intro. Holistic evaluation of language models, or HELM for short, that's the main project that I work on. And it is both a research project in the sense that it has published papers. It has a paper by the same title, HELM, which has more than 50 co-authors on it. And it also encompasses this open source framework that you can use to reproduce the results, or you can actually use to evaluate, you know, your own models or using your own data sets. So essentially what we do is this framework has integrations with a lot of different models and a lot of existing benchmarks. So a benchmark you sort of mentioned this earlier, but a benchmark might be something like, give the model, you know, questions from the law exam or from academic exams. So for instance, a popular benchmark that people talk about a lot is MMLU, Massive Multitask Language Understanding, or MMLU for short. And that's literally academic exams from high school level and university level from across a number of different subjects. And you give those multiple choice questions to the language model, and you see if it can get them right. So what Helm does is we've picked a lot of these existing benchmarks, and most of these benchmarks are they are existing papers from the literature, so they have been peer reviewed, they've been established for a while. And one of them, we've sort of collected them into a meta benchmark, and we've taken the set of papers or benchmarks that we decided on, and the set of models, and we've basically evaluated every model on every benchmark. And we do this in a way that is standardized and comparable and also transparent. So you can go see like exactly all the requests, you know, the exact raw requests that we send to each model and all the raw responses we get back. And from each of these, you know, these benchmarks and models, we compute some metric number, and that, you know, we build a table of all these numbers. And that is, we call that the Helm leaderboard. And if you go on the Helm website, that's what you see. And you're right that certain model developers have used that for marketing. They'll say, we get so-and-so rank on the Helm leaderboard. The open source software part of it is like, you know, people want to do their own evaluations. So they want to know, okay, if I have a new use case, like let's say I'm trying to use a model in a medical application or something, and I have a medical, you know, data set or benchmark. You can go to Helm and say, okay, run this model on my benchmark. Or if you have your own model, you can say, okay, try my new model with this benchmark, and you can use that for comparisons. Like you can use this to run like model evaluations.
Okay, awesome. And I'm looking at that, and I'm linking to that in the show notes. So if you're watching this on YouTube, just scroll to the description. If you're listening to this in whatever podcast player you're using, click the notes, and you'll be able to see a link to this, and you can see it for yourself. A holistic framework for evaluating foundation models. And it looks like Llama 2 is currently the winner. I think the 70B is like 70 billion parameters. Is that what that means?
Yeah, that's actually from the original paper results. So the original paper results, we have an updated version, which I'll send you so you can link it. But the current The current latest leaderboard, I believe GPT, one of the GPT variants is on the top right now, the GPT-4 variants.
Okay, awesome.
So
Yeah,
we benchmark a bunch of like closed source models like OpenAI GPT models. We have Google Gemini and Anthropic Claude. And we have some open weights models like Mistral and Meta Llama and a few more. Yeah.
yeah, and for the benefit of people who are unfamiliar with like weights and the meaning, the significance of that, maybe you can talk just like, LLM 101 or neural network 101,
Yeah.
like what weights are and why it's important that you open source those as well as the model
Yeah,
itself.
good point. Yeah. So let me back up a bit. So a language model, most people at this point are familiar with ChatGPT as
Right.
as an example of a language model. So a language model is a model that takes in text input, like you give it instructions, and then it gives you text output, like sort of like an assistant response. And these models have been trained on a large amount of text, like a large corpus of text, which is usually internet text and from some other sources. And when we say model, like this is sort of like these are all essentially deep learning models on neural networks. Specifically, they use a architecture called transformer. But you can think of it like you can think of it as quite similar to other forms of like deep learning or neural net models, where it's a network of parameters, and these parameters are trained based on the input corpus. So when you think of like GPT, like ChatGPT or Google Gemini, these are typically models that you access through a company's web application or mobile application or API. So you're essentially sending the text over the internet to their servers, and they're sending you back the responses. So it's essentially they're running the service. So this contrasts with what we call open weights or open source models, where you are essentially running the model on your machine you control, like on your laptop or your desktop, and you're running it as a program, and you're sending it the input and getting the output from that program. A lot of the most powerful models right now are closed weights, meaning that the companies do not make the model weights or parameters. So I use the term weights and parameters interchangeably.
Okay.
It's basically like here are the numbers in this network that you use to compute the text output from the text input. Right? You can think of it as sort of like a program. Most of the largest models right now, or the most powerful models, are closed weights in the sense that they're only available as a service running on, the company's servers. So this includes OpenAI, GPT, Anthropic Claude, Google Gemini. This is in contrast with open weights or open source, which is things like Meta Llama, AI2 Olmo, Mistral by Mistral, which you can actually download these on your computer and like run them locally and run them like a program, basically. Like you give it text input, it gives you text output. This is sort of significant because the closed models have been sort of posing a problem for the research community because we don't know a lot about them. We don't know a lot about what data goes into them, what the weights are. We can't do experiments on the program because we don't have access to it. So a lot of the work, like a lot of the discourse in academia is like, how do we get more open models that we can run experiments on, and how do we get them to be as good as the closed ones? Because right now there's a big gap between the open and closed models.
Yeah. And how big is that gap, and is it narrowing?
The gap is narrowed significantly because of a couple of specific companies actually, and one I'll mention is Meta, which is Facebook's parent company. They have open sourced, or I should say not open source. They have released an open weights model called Llama, or a family of models called Llama actually. The latest version is called Llama 3.2, and this is interesting because it is a model that is produced by a big tech company. So they have access to a lot more data and compute than,
Yeah.
say, at Stanford University do. So they have been able to
Yeah.
use these resources to like produce this very high quality model, and they are releasing it under a license that's actually not open source. It's actually a very weird license that has some restrictions on use. So it's not considered open source in the traditional sense. But because of that, like that model is very similar in capabilities to the other models I mentioned earlier, the closed ones that include Gemini, Claude, and GPT. So I think that has given people a lot of hope that maybe the open models can catch up. The catch here is that when I say open, I've been using the term open weights, which is a little different from open source. And the reason
Yeah.
I say open weights is that if you think of what the source is for a model, so when we say open source, we usually mean that in the traditional software sense, we mean that you can look at the source code, right? You can see how the program was built, you can understand it, you can reverse engineer it, and you can make modifications to it and rebuild it. In the context of machine learning, there's a question of like what is the source code? Certainly, it's the model code, so like the code that trains and generates the text outputs. But it's also the data. You also need the data that you train the model on in order to like create this model. And Meta has not released the data behind this model.
Yeah.
And so
And
that's
there's
why we call
probably
it
a lot of reasons why they won't release it, because I imagine it
there's
has
a lot
incredible
of reasons.
intellectual property infringement. So just to be clear, we're gonna talk more about this. I just want to give some context. So Meta is Facebook, like they just changed their name, but it's the
Yes.
same, Mark Zuckerberg company or collection of companies. He acquired Instagram, he acquired WhatsApp, and those are like, but he has infinity money practically. He can subsidize, he can build things like open weight models just speculatively because it costs like maybe like 1% of their operating budget or something to train like these models and to release them. So for them, it's like good PR, and I think it's cool. I'm glad they're doing it, but I'm confident that if you actually looked at the source for all these different and there are ongoing lawsuits like the New York Times, Reddit, like all these companies are suing. I think all the foundation model companies, and they're probably suing Facebook too, because just because they made it open model or open weight doesn't mean that they didn't infringe upon their work. But I guess what I'm trying to say is like they wouldn't put it out there as like, here are all the books we stole and all the Reddit articles we scraped and all the FreeCodeCamp articles we included, because we have thousands of articles that are almost certainly
Probably,
in these
yeah.
models. Yeah. And to be clear, like we don't have any ongoing lawsuits with these model makers. I wish they would credit us, but we're not going to waste our scarce donor funds to go and try to launch some speculative lawsuit against OpenAI or against, Mark Zuckerberg. Like we don't have the money to do that. But like I just want to be clear. Like if anybody's like, oh my goodness, is Quincy like somehow endorsing the way that these were built? Absolutely not. This is not like a talk. This is not a conversation about like ethics or anything like that. Like we're just, how did we get here? That's what I'm trying to ask. That's what I'm trying to establish. Like, so please don't like read into this as like, oh, Quincy's tacitly endorsing the theft of a whole bunch of intellectual property. We were robbed too, right? But now that these models are out there, and they are out there, like let's understand how they work and how we can potentially use them, because the genie is kind of out of the bottle is the way I see it. And hopefully people will be compensated, and maybe FreeCodeCamp will get our check someday too. And but anyway. I just wanted to clarify a few things for the audience and make sure they understand. So llama is like the animal with the long neck. LLAMA. I think it's like they originally had the L and M were capitalized, but it was really confusing because it is an LLM, and it's a clever name. but that's what we're talking about here.
They had a cute capitalization, but they changed it, so now it's just spelled the normal way.
Yeah.
You might also actually accidentally be a plaintiff in one of these lawsuits, because one of these is a class action where the classes all GitHub open source authors.
Okay.
And I think the wait, is it the plaintiff or the, I don't know, like a
Yeah, yeah,
party?
yeah, yeah.
Yeah,
The defendant and the
the
plaintiff.
OpenAI lawsuit.
Yeah, so OpenAI is probably defending from the plaintiff, which is probably GitHub. So
Yes,
I'll look forward to
exactly.
getting
Or
our check for
GitHub or
2 cents
open
in
source
the mail, which
notebooks.
is
Yeah,
like
exactly.
I've
So
randomly gotten checks in the past for like 2 or 3 cents from some,
so
and
you
the
might
lawyers
get
took all the money.
you might get a 3 cent donation from OpenAI at some
Yeah,
point. Yeah. So yeah, and like this is something that our lab thinks very much about, like the ethics of this thing. I would say that like it's not very settled yet um what the ethics and the legal framework around this is. Like as you mentioned, there is a lot of material going to the training that's probably encumbered by IP rights, intellectual property rights. It's unclear if they're allowed to do this. It's unclear if the copyright applies to the outputs of the models and whether those outputs can be considered to be infringing. There is some, as you mentioned, there is some cases going through the courts. So eventually there will be a case law around this that will clarify some of this situation. There's also a lot of activity in the US government around this. So for instance, the US Copyright Office had a number of listening sessions last year or this year about essentially asking artists and writers and musicians to weigh in on the impact of generative AI. And if you're interested in those topics, like those transcripts from the Copyright Office are all public, and like those are great things to listen to and hear what what concerns people have. So like personally, I share many of those concerns, and definitely like things that we think about is like we think about things like how do we compensate people fairly? How do we ensure that artists don't lose their jobs or get displaced by technology?
yeah. So, like setting aside a lot of those concerns, I think that is really interesting, and I want to make sure like I'm not dismissing those concerns, but I just don't want to spend like our scarce time together talking about those kinds of things when we could be talking about the actual technology, right? Okay, so you have done a great job of describing how these systems work, and now maybe you can talk about like just briefly like the process of benchmarking, like how do you put these models through the paces, and how do you figure out which one comes on top? And I love this term win rate. Maybe you can describe what a win rate is.
Yeah, the win rate is actually probably the most innovative, but also potentially confusing part of this benchmark. So we run a bunch of different benchmarks, right? So you can think of HELM as a meta benchmark. And the benchmarks are things like academic question answering, solving math questions, doing translation, answering like domain specific questions like medical and legal questions. And the win rate concept is kind of what's the probability that this model does better than another model, given that you pick a random competitor model and you pick a random benchmark. So it's a way of like doing this aggregation that is sort of reflects, all the components, all the different benchmarks that goes into it. And in terms of like how we do this evaluation, like each benchmark is actually a little bit different. So for instance, the multiple choice questioning answering benchmark, that's like easiest because like if you're just asking the model, hey, here is a math question, is the answer A, B, C, or D? You give it the question, you prompt it with the question via text input, and you just get a text output, which is A, B, C, or D, and you just score whether it's the correct letter or not. So that's sort of easy. But it gets more tricky when you do more open-ended things. Like say you're asking like a model for medical advice, for instance, which I do not recommend doing, by the way, in a real life context. You get back some piece of advice, like a paragraph, and the question is like, how do you score this, right? So you might have to actually find a real doctor and ask them, is this actually the correct answer? You might have to have you might have to have like a textbook reference answer that you check, is this similar or not? And there's some other techniques like for use cases like what we call instruction following, which is like behaving like a helpful chat assistant. You could ask humans, is this response helpful? Like I've asked it for a recipe, is the resulting recipe helpful? And then there's more recent techniques like what we call LLM as judge, which is literally you ask a second model if the first model's output was helpful or not. And usually it does a pretty good job of figuring out like what humans would like.
Interesting. That's so interesting that you got your like stand-in human, so you can automate things, and you're like kind of automating human judgment, and the model probably doesn't even realize. Well, obviously it doesn't realize because it's just an LLM, but like it may not even know that what it's being fed is from another LLM. Like even if they have some code like ape, not hurt ape, or something like that, like
there's definitely benefits and disadvantages to doing it. Like it's a lot. I mean, it's a lot more scalable. You can do this for like tens of thousands of millions of requests quite cheaply. But on the other hand, actually it's like tens of thousands, hundreds of thousands. But on the other hand, other researchers get suspicious. They're like, are you really sure that like you're measuring what this corresponds to what humans want, or is it just what like the AI overlords like want? Is it actually what we call aligned to human values?
Yeah, that's a very interesting kind of. We could delve into the philosophical questions associated with what do humans actually want, right? Because we're not talking about like a monolithic, humans, like many humans are bad actors, or have like weird narcissistic tendencies and stuff like that, and will just maximize their own value. Many people will play like those economist games, and they'll just take all $20 for themselves and give the other people $0 because they just don't care. They're sociopathic or something, right? Like so, but one question that immediately springs to my mind when you talk about having LLM as judge, I think is the way you described it. Does that have like a synthetic data type problem where like LLMs are creating data synthetically because they run out of like organic data that they've scraped off of Reddit, and suddenly it's kind of like this inbreeding phenomenon or something where like genetics keep getting like miscopied or something like that? Do you have that same kind of phenomenon when you have LLM as judge where biases are reinforced or weaknesses in models as a whole are reinforced by having LLMs judge other LLMs?
Yeah, so maybe yes and maybe that's sort of an open question at the moment. So this is more so like one factoid is that we found some researchers have found that like GPT, if you have GPT be LLM as judge, it's going to slightly prefer its own outputs over the other models.
But that's like very human, right? Like if you had a human judge their own writing from like 5 years ago, they'd be like, "Oh, I really relate to this." Like maybe they completely forgot they wrote it, but they're gonna feel kind of like subconsciously like this affection, this sentiment toward their own work, right? Like everybody loves to hear their own voice. Everybody loves to see their own name in print, right? If you want to have a popular, successful local newspaper in 2024, first of all, I don't think it's possible, but the first rule is you go around and you interview every single citizen and you make sure that every week there's like an article talking about some citizen so people can read about themselves and be like, and so is that an emergent phenomenon among LLMs, them preferring their own work? You just said it was.
Yeah,
but like
most of them seem to have this behavior. And I think the other part of the question is like, you were mentioning running out of organic data. So right now, the LLM training pipeline, you start with this massive corpus of text, right? And then there's also a phase which we call post we call it alignment or RLHF is another term for it, or post training, where you essentially have humans look at model outputs and annotate them, teach them what useful responses are, and then you train the model some more. And that produces like the assistant-like behavior. So that's all like humans in two parts of the pipeline, right? The first part, like the massive corpus of text that ultimately comes from humans, and then the post-tuning that's also like coming from post-training. That's also coming from humans.
Yeah, and just to define an acronym real quick, you said RLHF, reinforcement learning with human feedback,
from
right?
human, yeah, reinforcement learning from human feedback, RLHF. That's a term for human annotators. Basically teach the model how to behave like a question answering assistant or conversational assistant.
Kind of like giving them carrots and sticks. Like, oh, you did good here. Here's a carrot. Like, here's some like
exactly
utility
exactly.
or
So
whatever
teaching
it
them to
is.
follow instruction following training. So both of these, like people have been thinking like, can you replace either or both of these with, some sort of model? So RHF actually there is sort of a model component to it already. Like usually instead of using the preferences directly, you train an extra small model based on those preferences called reward model, and you use that. But I think the sort of bigger question is like, how much of this can you replace with AI? And the motivation here is, as you're mentioning, you're running out of data, right? That's actually
Right,
like
which
the
is
current
ultimately an
LLMs.
economic problem, right? Like, we could just pay people to write novels. Like, hey, I'm going to give you $10,000 a month to just sit down and write a novel a month. Like, we could like nano Readmo, like
Yeah,
a
but how
national
much?
write a novel a month, and then we could generate tons of work. Like, if we just budgeted it. So to me, synthetic data like has always seemed like the cheapskate kind of thing to do, where and having model judged as LLM, that just like gives me like inmates running the asylum type vibes. Like, of course, we can all save
Yeah.
tons of money if instead of having prison guards and all this stuff, we just have the inmates like self police but like that could go wrong in so many different ways. I don't know. I like call me a skeptical, but like I'm like the man on the street. I'm not a researcher at Stanford thinking about these things. Just my gut reaction is this might be a bad idea.
So there is the question of the volume of the data and the question of the quantity of the data. So in terms of volume, I don't think we can get much more than this. Reason is that like we're already using like massive scrapes on the internet. This is like, a lot of like, it's already a lot of human output, right? And some people say, hey, what if we have, we have private data as well, which firstly is ethically a bit sketchy. And secondly, I don't think that's actually the kind of data you want. I don't think that will improve things. And then there's the quality argument where some other folks are arguing, hey, the trick is not just quantity, is if you just train LLMs on textbooks that are written very well, very high quality textbooks by very knowledgeable authors, then you get like a good model. It's kind of like saying like telling a teen, go read books instead of like playing, video games or something like that. Right? Have sort of higher quality training.
Yeah, I mean, if you think about it, like somebody who's like playing World of Warcraft, they are technically going to be reading a lot of like crass comments and stuff as they're going on their raid, and they're going to still be exposed to a whole lot of text, but it won't necessarily be high quality text.
High quality text.
Yeah.
Yeah, there's like a lot of, Reddit goes into these models. So like these models are learning from a lot of very, dubious content.
Yeah. Like astrology subreddits and stuff like that. Like stuff like, sorry, apologies to anybody who believes astrology, but in my humble opinion, there's a lot of hogwash out there on the internet that these models are getting exposed to. And there's a lot of satirical articles. Like, for example, Google had the snafu where they were telling people to like, it was okay to eat a few rocks every day, or that it was okay to put glue on pizza because there were satirical articles about these that the model was not able to discern satire. The satire was lost on them, and they took it earnestly.
Mm-hmm.
So there's a lot of garbage on the internet too that is fed into these things. And now there's going to be a whole lot of synthetic data that it doesn't know is synthetic data, because we've kind of like entered into a new era where we've passed this Rubicon where, like, I mean, I could tell you, like, just from somebody who cares about SEO and does research, and like, we want freeCodeCamp to show up highly in a lot of queries, and a lot of our best articles are like under LLM generated articles. And it's very clear when you open it up, it's just an LLM, but Google's crawlers are not sophisticated enough to differentiate between LLM slop and actual, expertise written by some software engineer who's been working on this problem for many years, who sat down and wrote like a thoughtful tutorial, right? So I hope that doesn't sound like me airing grievances, although I am really pissed about it, to be completely blunt. I think it's nonsense, and it's a disservice to everybody, the creators and the audience is trying to use Google to get things done. And I know you're no longer at Google, so don't. I'm not trying to ask you to like go talk to the head of search, like, oh, Quincy Larson has this feature request, but yeah, like I guess where do we go here from here? It's crazy to me that the world is not enough. That like all text ever written by humans, every book, every blog post, everything like that's still not enough to train these models. That just blows my mind. That shows you how hard this problem is, I guess. But like we're out of text, and even if we paid a whole bunch of people to generate text, it wouldn't move the needle, is what you're saying.
So if you pay people to, I think maybe like again, if you have infinite money, what you could do is you could like try to license textbooks, right? You could try to get like the best textbooks out there which aren't in the corpus yet, and be like, oh, we'll pay the publisher or the author to let us use this for training, or maybe commission new textbooks, right? So that's one way you do it. And if the good textbook training hypothesis is true, then that might give you a better model. But in terms of like raw quantity, like my sense is this is really all we're going to get. With even like, I think like maybe a year ago, people were like, oh, let's just do video, right? Because there's tons of video out there. The problem is that people now are doing video, like the latest models like Gemini and GPT-4o are trained on video and images. So they have tapped on that already. And the last point we mentioned, like the AI feedback loop problem, there have been researchers who have run there's Stanford researchers who've run experiments like what happens if you just try to train a small model and have it keep training on its own training data. Does it eventually go off the rails, or does it self-improve, or does it stay the same? And so far the answer is it depends. Like there have been several people who've found that it does go off the rails, but there have been counter arguments that are like, oh, if you filter the data differently or you do the sampling differently, then you can fix the problem. So it's a little bit of an undecided question right now. Personally, my money is on no, you can't train a LLM on itself forever.
Well, so in a very constrained domain like Go, right? AlphaGo, they originally had like tons of training information. This is my understanding. Keep in mind, I'm not a researcher. Everybody correct me. Just correct me if I say something incorrect, please. But my understanding is they had a bunch of training data. They had like all these games played by like high-level Go players, and they trained AlphaGo on that originally. And then they realized, oh, well, we can just have it play itself in computer time. So like thousands of years of playing itself. And eventually it'll like discern the rules and kind of like build up from first principles how to play Go really well. And that was like how they did it, because they didn't have enough training data, or they just found that worked better for that specific use case. Is that what happened?
Yes, that's actually what happened. So there's this concept there's firstly the database, like training on original players. And then there's the second part, which they call self-play, which is essentially you take 2 copies of AlphaGo and you play, or many copies of AlphaGo, and you just play it against itself, right? And that gives you lots of games, and you can use that games as training data. And this sort of works in the AlphaGo setting, because Go is a game with a fixed win condition, right? Like you want to win, basically. There's a score, there is a concept of winning and losing. The problem with trying to apply this to LLMs is that when you're talking about a assistant, the concept of winning is very unclear, like what we call the utility, like how useful it is. So we mentioned LLM as a judge earlier. You could, in theory, try to generate try to have models talk with themselves, have LLMs as a judge, say like these are good conversations, train on these good conversations. But that doesn't really work in practice, because the LLM as judge, like this, there's so many issues with this pipeline, but one issue is like the concept of goodness is just so undefined, because in a human language context, there are things like helpfulness, creativity, like values, like more intangible things that we care about in conversation that's sort of hard to measure or tell like a model how to measure. And it's like that really makes it like difficult to, try to steer a model towards this, North Star, because you don't know what the North Star is.
Yeah. Yeah, I mean that goes for humans too. Like on the forum, if you look, like the FreeCodeCamp forum, pretty active forum, maybe like 7 million visits a month. People just helping each other with programming questions and encouraging one another in their job search and everything like that. And you can like heart replies, and you can like even mark a reply as a solution, which is a lot of signal to us, because we're trying to like figure out who are like the most helpful people, so we can figure out whom to grant moderator privileges to and things like that. And so the moderators can like kind of like pick out like stars, because we want to establish like top contributors of 2024, right? We're going to publish that soon. Like it's probably out by the time you are listening to this. But basically, of all the open source contributors and people active in the community, like we have to make judgments about who's the most helpful, right? And so that is extremely difficult for us to judge, because I mean it could be the thread is on just a really popular topic. Like if you go sort Stack Overflow posts by number of upvotes, a lot of times it's just like some ubiquitous technology like Git or Vim or something like that, and people have asked questions about that, and because everybody's Googling that and they're like, oh, this helps, and I'm like, because it's a more prominent question, it gets more signal in the form of upvotes. And then perhaps the most eloquent, helpful answer to a more obscure question would not get similar. Like, is there a similar consideration in judging models? Like if you're giving it some relatively esoteric task that it is uniquely qualified to do well over other models, like do you weight that additionally? Like, for example, you said legal advice, right? Like that is the realm of expertise. People who've spent their entire careers immersed in the law and understanding like the precedent cases and all that stuff, and understanding, like probably having some intuitive grasp, some intuition they built up from just doing this for so many years. And if you have an LLM that can give good legal advice that a lawyer would actually say, oh, that's pretty good, you're going to weight that specific task much more than somebody who can like, solve, a basic, math problem or something like that, right? Because like a lot of models. So how do you, when you're actually establishing how to rank these, and you're establishing the heuristics, the rubrics for which you're evaluating these models, how do you weight different types of expertise, and how do you think about like models that are exceptional in a difficult area and separate those from models that are just like generally pretty good?
Yeah, so this is a very complicated question to unpack. So firstly, ultimately, we want models that are sort of useful for people in professional settings, right? So, for instance, like right now, like ChatGPT is sort of great for party tricks, but there's a bit of a question, like if you were a lawyer and, in law, there's situations like, okay, I want to go look at all existing case law that's related to my current case, and I want a summary of that. That sort of sounds like an LLM task, right? So like lawyers have been thinking about, and researchers have also been thinking about, like, can we get it to do this? And the answer is, it's sort of like it depends very much on which professional domain you're talking about, like law or medicine or something else. And it also, there's also just not a lot of like applications being used, like real applications being done right now. Like I'm sure you've seen there was this story of like some lawyers tried to ask ChatGPT for case law. ChatGPT made up some fake stuff. They showed it to the lawyer to the judge, and they got into trouble.
The judge tried to look it up, and it didn't exist. Those DOIs or whatever metric they're using were not accurate.
Exactly. So there is a sense that there's like a suspicion that GPT like is not ready for a lot of these real world professional tasks. And what we've been trying to do in the lab is like we've been interested in finding like specific professional use cases and trying to build benchmarks around them to see like, hey, here's what it looks like in a real life situation. The problem is that a lot of these benchmarks don't exist right now. And there are many reasons for that. Like, firstly, you need professional experts to build those benchmarks, and the time scarce. And there's secondly, a lot of these data, like for instance, if we talk about medical benchmarks, it's very hard to get medical benchmarks because of privacy and data protection issues, medical data. And then there's issues like there's also like the sense of I think not all the domains have equal amount of attention on them. So, for instance, because LLM research is done by programmers, there is a lot of programming evaluations. Like there's a benchmark, for instance, which is like, can you take a GitHub issue and write a pull request for it? Which is kind of a reasonable professional task that a real engineer would do. And my suspicion is like the reason there's so much work on this is because like we are computer science people. We want to like scratch our own itch. So there's a lot of work on that.
Yeah, and it's a domain we already know and understand because
exactly.
we've all, like most computer science people would probably open a pull request before, or at least read a GitHub issue and had to think about how they would go about solving it.
So I've heard this term called the Ragged Frontier of LLMs, which is exactly this idea that the LLM might not be as capable at every, may not be capable at every subject. Like it might be, hey, it's awesome in law, but it's not great in medicine or something. So ultimately, you kind of have to do this evaluation case by case for each, use case they actually want to use it in.
So the ragged frontier, ragged like a torn cloth would have. Exactly. I mean, it's going to be longer in certain places than it is in others. There's going to be kind of maybe a zigzagging pattern, and so that pattern is zigzagging across all these different domains of expertise.
Yeah,
and probably the most explored is software development, just by virtue of it being so close to us, and by programmers put tons of stuff on the internet. We've got like 20 plus years. I think it's probably about 20 years worth of Stack Overflow posts, right? At this point, we've got almost 10 years worth of freeCodeCamp question and answer threads. We've got like just tons of programming tutorials that have been published in video form, for example, and O'Reilly books and like all these other things, right?
Yeah, if you look at the training data, so there are some papers that do publish, what goes in the training data of LLMs for certain models. It's a lot of programming material, and some of it is exactly what you mentioned, right? Like programmers, we live on the web, so we're more inclined to share on the web. There's things like Stack Overflow, which is very mature infrastructure for sharing knowledge on the web. So some of it is just because there's vast quantity of programming knowledge on the web that, that coding stuff, like also all of GitHub code as well that exists. So all of that, there's a lot of programming related material that goes into LLMs. And there's sort of a question of like, does that, there's a hypothesis that this is good because the programming knowledge, people hypothesize that the coding teaches the model how to do other things like mathematical reasoning or logical reasoning as well, because they're such similar skill sets.
Yeah, wasn't that a big unlock for GPT-4? Like I remember they included they kept changing the name of it, but it was basically like it would write code and then it would show the code that it used to come up to arrive at a conclusion. It's like some sort of chain of thought. Yeah. But it would you could actually see the code and you could look at it, and that was like a huge windfall for me to like better understand how this thing was quote unquote thinking, was to be able to see like, okay, I asked it a question like how many airplane seats are there manufactured in the US each year, and then it would go and like figure out like the plane production and stuff like that or something. I don't know. But do you think that that is like a big part of so by teaching it so much about programming, and what I always try to think of programming, what I try to communicate to people who are learning programming is really just thinking and like trying to really distill your thoughts into clear instructions that can be interpreted literally by a machine. It's like the highest form of precision communication possible outside of like maybe like law, right? Law is literally called code, right? Because it's like if this then that, right? And that kind of like logic that essentially runs entire nation states. And similarly, code, like if you look at the Linux kernel, if you receive this type of input, return this, or call this function, which will figure out what to pass back to this, and that might call several other functions. And it's like this hierarchy almost, like, and it's somewhat deterministic. And so by thinking like you're programming, it forces a certain rigor to your thinking. And I can see how that'd be very useful to force the LLM to explain itself in similar on a similar level of rigor.
Yeah, I've actually heard a lawyer describe law as programming code before. So I think that's also not like necessarily true, because like in humans, we deal with a lot of ambiguity.
Yeah.
And one of the things LLMs are quite bad at right now is dealing with ambiguity, like dealing with ambiguous questions, so recognizing ambiguous questions. So that's kind of interesting. But also, like, I do agree. Like, I've heard like the reason you teach code, like it's not like a big benefit of teaching coding to students. It's just having them gain that mathematical reasoning or that logical, the reasoning skills.
Yeah, it does teach you, like, there's the famous Steve Jobs quote, everybody should learn how to, program because it teaches you how to think, right? Of course, famously, Steve Jobs didn't know how to program, so he needs to take his own advice. But you could definitely extend that to everybody should learn how to program because it teaches you, critical thinking and logic. And importantly, it teaches you communication skills. I think that's been a huge unlock for me, the precision. When I started hanging out with programmers, I was used to teaching, hanging out with teachers and stuff. And like the level of specificity, if you use a phrase like casually, like, oh, well, as a matter of fact, I did. Is that a matter of fact? Like people would ask those questions. And I'd be like, oh, I'm not sure if it's actually factual that is the case, And like all these like little kind of like things that we use in English are extremely imprecise. But humans are extremely good at interpreting ambiguity, and like the human brain seems to be structured very well to differentiate like a twig on the ground from like a snake and things like that, right? Whereas a computer might see that shade and they might mislabel it, or they mislabel muffins as chihuahuas and vice versa and stuff like that, right? So obviously that has improved a lot, but that just goes to show that like humans have so much sophistication in their perception, and it's going to be an extremely long road to get computers to be able to have that flexibility that the human brain shows.
Yeah, definitely. I think a lot of this early work, like if you look at HELM, a lot of the evaluations we do, a lot of early evaluations are just things like, can you answer multiple choice questions, right? And that's very different from, can you hold a long conversation with a person? There's like so much to do with, we talked about ambiguity, but there's so much more skills as well involved in that, right? And I think it's just a long way to go. There's some people working on this social aspect. It's more like, do LLMs have social skills or social intelligence? Can they reason about people? Can they can they persuade people? Can they understand emotions? Can they understand puns and humor? And that is very much an open question right now.
Yeah, and so I have so many questions to ask about the capabilities of LLMs because I think they're probably both overstated and understated in various, public reports and stuff like in the media and stuff like that. What are some of the most impressive things that you've seen an LLM do over the past 6 months or so?
Well, that's a difficult question. Most impressive thing. So I think my sense of impressiveness is a little skewed right now because just like hanging around. Okay, I can give you an example. So, so there's a famous mathematician, Terence Tao, and recently he was basically given a preview access to an OpenAI model called O1. And O1 is a model that does chain of thought reasoning. So we mentioned earlier, chain of thought reasoning is when the model is, you ask it a math question, instead of just giving you a short answer, it's going to try to like generate a few, a section of text that is like reasoning about the question before it figures out what the answer is. So, so he was given this model to experiment with, and he basically gave the model a few he asked it to help him with very high level proofs. Like he asked it to translate one of the proofs into a theorem proving language. He asked it to write a novel proof for another problem. And he actually ended up saying like, okay, this model behaves at the level of a mediocre grad student. And the internet response was like, wait, how have the goalposts moved so that like 10 years ago, if a model was able to write a graduate level proof, that would be amazing. But now we are like, oh, it's a mediocre graduate student. That's not impressive anymore somehow. So I think that was a pretty impressive demonstration. Like the fact that you can actually use it for high level, research mathematics, and it actually produces some value.
Yeah, I mean, I use them all the time, and I continue to be impressed with them. Like just yesterday, I took like a giant PDF that we created years ago, and I'm like, I don't want to go through and manually like convert this PDF into JSON, like get the properties back out. I can't find the original properties I used to generate the PDF. And I just said, hey, figure out, like I gave it to GPT-4o, and I was like, figure out how, like what the structured data is in this PDF. It's like, 10 pages long, and turn it into JSON that I can use for a REST API. And it did it. It did pretty well. I had to fix a few things.
Common uses.
Yeah. I mean, it's just an incredible time save. It's nothing that I couldn't personally do. I could probably do a lot better job than it did, but it's like having my own mediocre grad student who's doing my exact bidding. And who's I don't have to call somebody and wake somebody up, right? I just jump in there and nobody's really inconvenienced. OpenAI spends, $1 or something running my tasks. And, I just got what I needed to get done. I was talking with the guys from the Changelog yesterday, the hosts of the Changelog, the big open source podcast, and they said that they think that LLMs have made them 20% more productive as developers. And I mean, if you think about it, 20% more productive, that's a huge change in productivity. Like, not since like spreadsheets and scripting languages, or I'm trying to think of the fundamental changes, maybe Google search that have unlocked that amount of productivity. So it is a massive change in productivity. But what I want to ask you, do you think this is just the beginning? Or do you think 20% is like good enough to justify the valuation of NVIDIA and like all these other, all the investment in the space? I mean, do you think that this is just the opening volley of the productivity that's going to be unlocked by these tools? Or do you think we've already kind of gotten a lot of the initial benefit, and there's going to be, asymptotically diminishing like returns going from here?
Yeah, unfortunately, I'm an AI skeptic, actually.
Okay.
So I would bet on busy. Like, I think that's the extra question of like you're mentioning there's like literally hundreds of billions of investments that has gone into AI, tens if not hundreds. So like there's a question of like, are we going to get tens or hundreds of billions of returns? And I think that, I don't know, I'm not really confident enough in either direction. The thing that I'm fairly confident about is that the pace is sort of slowing down. So the reason for that is that if you look at recent model releases, the pace of model releases hasn't really kept up. Like, there was GPT-3 and then GPT-4 after a year, and we're like, oh, maybe GPT-5 is now, but GPT-5 hasn't come out. There's rumors that the data question I was talking about earlier, like that's starting to be a significant question. There's some people think that maybe if we completely change the way we build the model, like if we use a completely different architecture, we can do another step, have another step game where we jump from here to something. But that's very difficult to predict. I think there's certainly a lot of people working on new architectures and new techniques, but it's very difficult to predict if one of them will bear fruit.
It is difficult to predict, but let me ask you to make a prediction. So we've had AI winners like all the way back since like the 1950s and stuff. Like, oh, this is no big deal. Software is easy. Like that's what they thought back at the time. They're like, well, we've already got these computers and stuff. Like we can do anything. We can simulate like a human brain, no problem. They greatly underestimated the amount of work. And, then there were like little hype cycles, like bubbles up of funding where suddenly AI was the big thing and then it died down. And like maybe every 10 years or so, I don't know the exact interval, but it was a pretty predictable kind of sine wave of interest. And maybe it was more like a saw wave. But now, more than ever, we've got tons of interest. We've got tons of money. We've got tons of very smart people like you working on AI, either working on AI at, Google before you started working at Stanford researching AI and trying to evaluate AI through your benchmarks. Now that we have so much attention on this, do you think that dramatically increases the rate at which we're going to develop things? Do you think like that we would have to put in N hours of research, and maybe the collective amount of research put into AI over the past 50 years is the equivalent of what was put into research in, 2023 or something, right? Like, do you think that now, because there's so much attention, we are going to get those gains faster? Or do you think there's like other limiting factors besides people thinking really hard about this stuff? We just need more passage of time.
I don't really know. I mean, certainly the amount of investment into AI has increased by a lot, and even like researchers, like at Stanford, you can see a lot of research. Basically, a lot of researchers are working on large language models right now who weren't before. I'm actually not entirely sure that's a good thing, because if people go into LLM research, right, a lot of them are coming from somewhere else, like another discipline of AI or another discipline of computer science. And that's not necessarily, like, my concern here is that, like, okay, what's going to happen to those fields, right, that have fewer researchers? And I think the other thing is, like, I don't know. I don't know at what point you get diminishing returns, because like certainly there's like a lot of people trying a lot of interesting new ideas in parallel, but I don't know at what point, like how confident I am that one of those ideas will really allow us to like surpass these fundamental problems.
Yeah. In a lot of science fiction, obviously science fiction written before AI. So like one of my favorite series, The Expanse, the authors talk a lot about how AI is everywhere, but it's just kind of invisible, and it's doing little things in the background and making life easier and simpler and allowing humans to make the higher level decisions. But it's not like there's some overlord AI that's making all the decisions, and the president's an AI and all this stuff, right? So it's clear that like at least in that universe that they thought of, which is arguably like the most scientifically accurate like science fiction series ever, other than maybe like Arthur C. Clarke or something like that, but like very accurate, right? So those people who are not AI researchers, I don't think they're like software engineers, but they didn't think that AI would, become this huge thing. And they clearly thought that there were like limits to what an AI could do compared to human civilization making decisions the way that human civilizations have made decisions for, 100,000 years in small tribes and now as nation states and things like that. Do you think that it's possible that that is the future, and that even with all the hype and all the breakthrough that we're experiencing right now, we just experience like not a one-time step change, but a relatively infrequent step change, and we just have more step changes over the next few decades to look forward to, and that this is not going to fundamentally change everything, like a lot of people who are paid to say it's going to change everything keep saying?
Yeah, I mean that's so interesting, because like on one hand, I'd argue that we sort of kind of already live in that reality in some sense, and in some sense we don't. There are a lot of things in daily life that's basically AI, and we don't think of it as AI. Like generally, when something works so well, we start thinking of it as AI. Like for instance, email spam filters is AI, but we don't think of that as AI. And things like, so I'm talking more in the sense of like traditional AI, or traditional in the sense of like not LLMs, not generative
like if-then statements.
Some of these are still statistical models, not necessarily, decision trees, which is if-then statements.
Yeah.
Some of them are decision trees.
Yeah, sorry, it was a joke. But, I realize it's more sophisticated than like some programmer hard coding if-else logic, but.
Yeah, so in some sense, like I feel, like for instance, running a search query that uses AI in some sense as well, but we don't think of that. So we kind of like, in some sense, you can't really, like, we interact with AI every day. Like, if you use Facebook and you use, the algorithm decides what posts you get to look at. That's another example of AI. So, like, I don't think necessarily that all these applications of AI are positive. Like, for instance, I feel like we are sort of in this reckoning moment now where we are starting to think about the impact of social media on society, and the recommendation algorithms is part of that. In some sense, we live in that world, and in another sense, like, AI is very unevenly applied right now, because, like, certainly if you use a technology produced by a big tech company, like use a product like Android, for instance, Google is going to have a lot of money. They have AI infused in all of their products because they have the infrastructure and resources to do that. But if you're talking about lots of different domains, lots of different applications. So, for instance, one application that I learned about recently is weather forecasting. Google just produced a weather forecasting model that uses AI in a specific way that outperforms like traditional forecasting methods. And
wow, that's a big deal. I didn't even hear about that.
Yeah, that's also the thing, right? There's like a lot of fields where potentially you could use AI, but like it hasn't been done yet for for various reasons. Like maybe there are technical barriers, maybe there are social, political, cultural barriers. Maybe there might be genuine reasons why you don't want to use AI, right? There might be like legitimate reasons.
Yeah.
But it also might be a resourcing problem. Like, no one has there's no machine learning person in your weather forecasting office, for instance, might be a reason. So I think there's still a lot of like many domains where AI could be applied to a lot of social good where it hasn't really been done yet.
Yeah. So the future is already here, but it's just not evenly distributed. And
exactly.
I imagine over the coming decades, there are going to be lots of small companies, maybe solo developers, who take a lot of that Promethean fire, to trucking companies and to, farms and to all this other industry, and essentially make it marginally more efficient or maybe dramatically more efficient, dramatically improve the output. It's possible that like with, there was a period with chess where having a human player and an AI together was more powerful. Now it's just the AI's got the absolute advantage. But there might be a period where humans and robots are working like kind of in tandem to get things done better or to have better outcomes. Like as was the case with weather reports, I can just throw out a wild guess and get on TV, dress up in a suit and talk about the weather and be wrong. And maybe that's good enough for like a lot of people that are just glancing at the weather, trying to figure out if they need to get an umbrella or something. It's not like that big of a deal. But when it comes to, like estimating, like how many birth defects a certain chemical is going to cause or something like that, that could be like dramatically more high stakes, right? And so maybe the quality of those decisions is dramatically, it's not just a question of quantity, it's also a question of quality of output in a lot of cases. And so anyway, I'm kind of like rambling, but I'm just like trying to process what you said in the sense that we're going to be able to take a lot of the technology that we already have that may not be super sexy or exciting for people like you, not even for me necessarily as just a software engineer who like kind of like reads about this stuff on, and hears about it at dinner parties and stuff. But for, some farmer in Omaha who's trying to, or maybe a rancher who's trying to like have better organic beef or something like that, like maybe there will be some huge unlocks around the corner that is technology that's already like a year or two old that they just haven't yet, received in a packaged form that they can use, which could just be as simple as like some mobile app that tells them when to like feed their cows or something. I don't know. I know nothing of the domain of farming or ranching, so I apologize to any farmers or ranchers listening to this who are like tearing out their hair like, Quincy, you got us all wrong. That's not how we roll, But my point is, there will be a whole lot of domain experts who pick up more generic tools and then adapt them to their domain and then sell them to people in their field. So that is a huge opportunity, regardless of whether AI continues to improve. The step change we've had is already, it's just going to take years for us to figure out how to use, like even if you froze development and like just GPT 4.0, what I use every day, that was like that was how good it was, and it stayed that good. Hopefully it doesn't get worse, like Google search seems to be getting worse. Sorry, I know you used to work at Google, but I know you're not on the search team. I'll quit complaining about Google. But like ideally, like it just stays the same, right? And it's not like welcome to Costco, I love you, like trying to get product placement or something in there, but it's actually, just it's stabilized. Even that tool as it is incredibly useful. And I could see that dramatically improving my productivity over the next few years as I just learn new ways of leveraging those tools. So I'm extremely optimistic about AI. How do you feel?
I feel excited and scared. Like,
okay, let's talk about the scared.
Yeah. Okay. Not that excited. The scared. Large language models, they have a potential for a lot of misuse and a lot of potential harms. So, I can give an example of a few. So, for instance, in HELM, one of the recent projects we did is we basically said, can you use a large language model to produce harmful outputs, where harmful outputs might be instructions on how to build a bomb. It might be it might be things like political disinformation that you can post on social media. So we had this evaluation, this benchmark that was essentially, we sent, a model, a lot of requests for these harmful outputs, and we measured, how often do these models give you the harmful output? And the answer is actually quite frequently, depending on the model. So some models are better than others. I'd say that overall we were quite impressed by the amount of safety tuning that the developers were able to do. But regardless of the model, we still found unsafe outputs. So I think I'm so worried about all these potential harms in terms of disinformation. And there are also things like bias and fairness, the idea that models might be biased against certain groups of people or might not work as well for certain groups of people. There's also, I think, concern about labor displacement. Like if models can take over the jobs of people, does that mean massive job loss? And economists are split on this actually, because they also argue that AI will create lots of jobs. So it's possible that there'll be a structural shift, but overall, workers turn out okay. But
they're probably going to need education. Yeah. They're probably going to need some more education before they can get some new jobs.
Then go to freeCodeCamp.
We've got you covered. If you're worried about getting displaced, just keep learning skills and keep climbing, and the rising tide will stay below you, and you'll be okay as long as you keep learning. I just want to reassure people. I've seen nothing to convince me that work as we know it is just going to completely go away. I think a lot of that hyperbole is pushed by people who have an agenda. I don't think it's a practical argument that we're going to have some, AI system that can just do better than humans absolutely at everything, and that human labor is just no longer needed. We're all going to be rounded up and put in these, beige buildings, and we're going to, eat food and basically live dreary lives while a bunch of really wealthy people just have the rest of the world to themselves, and they have us on our UBI slums and stuff like that, right? I'm definitely legitimately processing what you're saying, but at the same time, I do want to kind of push back with I don't think it's all doom and gloom. Let's talk about Singapore. So you're from Singapore, right? One of the most advanced countries in the world. I think it's the third highest income level in the world, and the other two higher ones are oil trust fund type countries.
Yeah. The life expectancy is one of the highest. That's what we like to say.
So I talked with Josephine Teo. Josephine Teo?
Yes, correct.
Teo? I talked with her, and one of the things she said that was really interesting is Singaporeans technically kind of almost have a negative unemployment rate, if you want to think about it in that sense, that there are more jobs out there than there are people that can do the work. And so it's just a question of taking those people and giving the skills so they can do the better jobs that are open. And when I say better, I mean higher income, you could argue that like you can make a lot of money as a coal miner, but it's not a good job, right?
Yes.
Nobody
Yes.
would argue that being a coal miner is a good job because you're damaging your health, you're putting your body at risk. It's backbreaking labor. It's not very much fun, I would imagine, going down into a dark cave and like chipping away at the walls and stuff. Like you can teach a coal miner how to, work in a factory or do some sort of like slightly less dangerous, slightly higher paid type job, and you can level people up. You could say that like you could train somebody who is a field medic in the military you could send them to medical school and they could become a physician, right? You can always like level people up a little bit. And I think with Singapore, because they're actually trying to train people and get more people to become AI engineers, which are essentially software engineers who know how to leverage models and leverage these AI tools that are coming out with each passing month. So in a way, like even with technology improving and jobs getting automated away and jobs getting offshored and stuff, and like in the US, employment has stayed relatively stable. And you could argue like, oh, people are just getting discouraged and they're living in their mom's basement. Like this is the stereotype. They're living in their mom's basement and they've just given up on getting a job and they're just playing Call of Duty all day, right? Like that's what happened. And they're just, but if you actually look at the numbers of people employed, it's been fairly stable despite all the technological revolutions that have taken place in the United States, since the Industrial Revolution, like all of the computers and like the information age, all that stuff, right? And I have reason to be optimistic that this age will be similar and that it's going to take everybody and improve their productivity 20%. And the sixth person who gets displaced by that 20%, well, they're going to find some better job and they're going to keep climbing too. And I think my argument is as long as everybody's getting smarter and more capable and stuff like that, we should be able to figure out new things for these people to do. And I think the main reasons for unemployment and suffering and stuff like that is failure of imagination among the people that create the jobs and like terrible hiring practices, like applicant tracking systems and like, this Kafka-esque employment system and then our resistance to it and our us trying to hold on to old steelworker jobs and things like that when those jobs were never good jobs. They were all miserable, terrible, dangerous jobs, noisy, hazardous to your health. And most people would be better off and probably happier working in a cubicle somewhere or working from home doing like remote work than they would be smelting iron and being around all that heat and noise. Like that is my theory. So what do you think of that? Please shoot that down. Please poke as many holes in that. Please make me sound like a hopeless romantic.
Yeah, so actually I want to share a story from the conference that we both went to where we met. The one about a startup founder who was presenting a project that was building robots for farms. So this startup was building robots that could tend to strawberry plants and pick strawberries, and they were working with a farm in Watsonville or Monterey, which is a few hours south of San Francisco. And when I heard of this, at first I was very skeptical. I was like, isn't this just going to like make lives worse for farm workers, right? Because you displace farm worker jobs. But the story was they were running this prototype in the strawberry fields, and the farm workers would be very curious, and they would actually ask and go up to the engineers and ask them questions. And when they heard what they were doing, the farm workers were like, wow, this is amazing. When can we get this? And it turned out that they were saying that the job of picking strawberries was less desirable compared to some other farm worker jobs. And they would actually like for the less desirable jobs to be automated away. So in that sense, I think this sort of ties into how Singapore thinks about automation. Like instead of thinking of displacement, we think about augmentation. So the idea that instead of the technology replacing you, you are using that technology to be a higher productivity worker. You're working, you're deploying technology, working alongside that technology, which of course has lots of prerequisites. Like you need to understand and know that technology, and the policies, your workplace and government policies have to be favorable. So I kind of think of this like I think there's a lot of potential for AI to augment humans instead of replacing humans. But I think the big questions are like, who ultimately gets to decide, how the technology gets used. So it's sort of like a power argument where it's like, do the workers decide, or the unions, or the companies, or the big tech companies, or the government? And where does the power reside, and how do these decisions ultimately get made? So it's very much a question of politics and democracy and economic structure, I think. And I think what I worry about most is like the power is so concentrated in big tech, especially, in terms of money and in terms of, them having the models, right? The big tech has the large language models right now, the best ones. Like,
Yeah.
how much of the societal transformation will be on the terms of those large tech companies and large companies in America in general versus workers, unions, government, and the average citizen? I don't really have a clear answer to that.
Yeah. Well, let's say hypothetically, open source or open models, not open source models, as you pointed out, open weight models. They come to approach the performance on Helm benchmarks, and in all the ways that matter, they come to be comparable, and that freeCodeCamp can just host its own Llama instance, which we do. We use it internally for lots of things. And every organization, like a farmer, can just have a box at home and can host, the Minstrel or whatever they want, right? And in fact, I've seen lots of videos of people doing this, just having their own instance running that they can interact with and not having to pay for OpenAI. License like Pro. It's like $20 a month. It's not that much money considering all the usage it is. I'll be amazed if that price doesn't go up. But let's say hypothetically those models approach, and then like how would that affect that power dynamic if people weren't beholden to the giant tech companies? If let's say hypothetically, okay, two things happen. First, the open weight models become almost as good, and then the top of the line models start to plateau. Right? They do hit some sort of ceiling for performance, at which point, like kind of like iPhone, nobody cares about the new iPhone, nobody cares about the new PlayStation, because it's been good enough for years, and these marginal improvements in graphics or speed or anything are like almost imperceptible to the typical person. We don't care, right? Like, I don't care genuinely the difference between like a $200 can opener and a $1 can opener, right? It just opens the can and it works, right? Like what if it becomes completely commoditized and it completely plateaus, and it's just this new tool that we have, just like spreadsheets. Like, I'm sure Excel is better than Google Sheets and has lots more features, but I can't be bothered to install it and pay a bunch of money for a license and stuff when I can just use Google Sheets, right? Like, what if it gets to that point where all AI is just this thing that's kind of like a solved problem?
Yeah,
what do you think that would do in terms of impacting the labor market?
Yeah, I think I'm a little bit more optimistic about this future than I was a year ago. So, about a year ago, like the situation was kind of like you had to pay OpenAI to use these models, right? Or you use inferior models, and even if you wanted to use the inferior open weights models, you would need a very expensive desktop machine that would cost thousands of dollars or tens of thousands of dollars, like out of reach of like the average programmer, right? Like, so you sort of think about, if you think about this as another tool, like a programming tool, when I was a teenager and I first got into programming, my first tools were things like QBasic or PHP or open source tools that you could download for free and use, right? And the fact that you need a very large GPU or API it sort of like makes it so it's not free and it's sort of out of reach for at least some people. I'm a bit more optimistic that like it's gonna be more accessible because what happened over the last year is the small models got better. So now we have models that you can run on your like MacBook, for instance, or on a small laptop, and they work. They're not as great as GPT, but they work reasonably well. So I think like I'm a bit more confident now that this technology will be a bit more evenly distributed. Though, like as I mentioned earlier, there's still a gap. So we at Stanford, we're trying to train our model as well. We're trying to close the gap. The other researchers trying to close the gap. So that might come to pass. The one thing I'd still be pessimistic about is like even if you have a tool, even if you solve like the access of the tool and the openness of the tool, there's still the question of like who decides to get how the tool is used. So for instance, like to give one example, like let's say an employer decides to replace, okay, this is a very made up hypothetical, but let's say
Yeah.
employer decides to like fire all the paralegals, replace them with an open source model. There's still the question of power, right? How did this decision get made? Like, the fact that the tool is open source doesn't, reduce the harms to the paralegals who got fired. And then a more concrete example that I just learned about is like, for instance, the state of Nevada is partnering with Google to try to use LLMs to process unemployment benefits claims. And this is freaking a lot of people out because there is
Yeah.
like
I mean, what if it makes
yeah,
a mistake and you don't get your unemployment?
exactly. So this is like a really high stakes, high risk deployment, and like experts are very, very concerned about how things can potentially go wrong. So I think
Yeah.
it's this is the other question there, like who gets to decide like that the state of Nevada, like how policies made, how the policies what kind of these users are allowed by policy.
So here's my thinking on this. If you're interested in hearing my thinking, my relatively naive thinking. I don't want anybody to think like Quincy's just spent hours and hours philosophizing and like writing treatises about this and stuff like that.
No,
But
this is great.
like in theory, let's say that a whole bunch of false negatives happen or a bunch of false positives, or like, I mean, I'm sure Nevada's going to encourage the LLM and probably encourage Google, can't you make it deny more claims? Like that, they have every incentive to do that. But like, is that really any different from just telling like their human evaluators, like, hey, try to find every single little loophole you can to deny people claims? Like insurance companies do that all the time, right? Like, yeah, you can definitely say it's even worse than what it's always been, but hasn't that been just like the progression of evil in society?
Yeah.
And is AI actually accelerating anything, or is it just making it a little like cleansing their consciousness a little bit, because it's not some human who has to push the electric shock button, but it's like a machine that determines to push it, right? You're like a few steps removed as a programmer who's just building the doomsday machine, as opposed to somebody who's actually going out and like executing people directly on a firing line.
Like, I mean,
Go ahead.
The real like I mean, people are making that counter argument, exactly the counter argument. So, for instance, there's research showing that, for instance, like anyone who makes a decision in judiciary or like in a government office, they're not free of biases, right? They will still make decisions based on bias, sometimes unfair decisions, sometimes incorrect decisions. And now the objective for AI, some people argue, is not to be perfect, but just simply to be better or less biased or less incorrect than the human baseline. And I think to some extent that might be possible, but it's very difficult, right? I feel like in academia and in research, we sort of understand the nuances of like, hey, how do you measure these things? How do you measure fairness and bias and, accuracy? But really the worry is like how in the real world, how often do people care about these? How often do people get it right? So definitely there's a way to do it right, I think, but it's very difficult.
Yeah, and I just want to be clear that like I think these companies should, like these giant, entities that have lots of money, should err on the side of trusting people that are filing unemployment claims. People that like, I understand. Like I just watched this great movie from like the 1940s called Double Indemnity, and it's all about like insurance scamming, basically. Like, but it's from the 1940s. It's like this noir movie. It's very, very good movie if you want to watch a really old movie. Practically public domain. But yeah, I understand that people are going to try to cheat and like fudge numbers. And there's this great movie called Blue Collar that I watched from the 70s where the main character, he's Richard Pryor. He's pretending he has 6 kids instead of 3 so that he can get like additional child benefits in his tax deductions and stuff like that. And that's like a major plot point. And like, I understand, but like these are often extremely destitute people, and I feel like we just need to fundamentally figure out how we don't have to put them in situations where they might feel pressured. And also, it's kind of like that, like whole principle, like you should. It's much better to like free like 10 guilty men than to falsely execute one who was innocent or something like that, right? I mean, it goes back to the foundations of kind of modern or like Western philosophical thought, So my thinking is like a lot of this stuff is human problems, and AI is merely the weapon that the human is pointing at the destitute person, as opposed to, So I definitely understand that is a huge drawback. Is it's going to give people like the illusion of like a clear consciousness when they're just as complicit and denying people sustenance and things like that. That is a really big issue to get into, and it's beyond the scope of this podcast. But I did want to weigh in and give what you said proper gravity, because that is very dangerous, especially with insurance companies, especially with like the area that it hits home most for me is as a teacher, seeing these people who were mislabeled as plagiarists by some AI that can't even accurate. Like people are out there selling tools that purport to be able to detect plagiarism, but are very bad at it. And you can copy something from GPT, open a new instance of GPT, you can paste it in, and you say, "Hey, GPT, most sophisticated LLM in the world. Do you think this was generated by an LLM?" And it may not know, right? Like, do you know anything about this? Like, have you studied like plagiarism detection?
The tools like GPT-0, that's like LLM detection, they're mostly not great. There are a few tools that, I would say that they're mostly not great right now. They're mostly unsolved problems. So any startup that's like, I have a perfect LLM detection tool is probably lying. Yeah.
But there's some CIO on a golf course with one of their salespeople right now. I guarantee you, school systems are buying plagiarism detection, and that is just the progression of evil. That is just the capitalist wheel turning, and people going out and following their incentives to like start a company and do enterprise sales and stuff like that, and convince people like, "Hey, I can save you all this time and energy that these teachers were spending trying to figure out whether a paper was plagiarized," right? And so I don't think technology introduces completely novel horrors. I think it's just kind of like a continuation of horrors that like these plagiarism tracking software is Turnitin and stuff like that. It's been around for decades at this point, and it hasn't always been accurate, and there's been a high number of false positives, and I think it's going to get worse because there's this false confidence that these tools work better than they actually do. But
I think that's definitely
sorry, I don't mean to monopolize the conversation. I want to be interviewing you, but I just felt like pointing that out. Yeah.
I mean, I think I'm scared of a lot of the same things as well. Like, I mean, earlier we were talking about, the large amount of investment in AI, and a lot of this is like C-suite executives, like not really understanding what the technology can do and throwing money at it, right? And you mentioned, this doesn't feel like a technology problem, it feels like a human problem, and that's exactly right. Like to do my spiel, like the organization I work for is called the Center for Human-Centered Artificial Intelligence. And a lot of the researchers who work at the center or collaborate with us are from other disciplines like law or policy or economics or business or other fields. And a lot of it is exactly because like there are these thorny ethical questions that you need, some of it is like fundamental Western philosophy questions, right? Like what's ethics? Like what's the ethical model? Should models be ethical? Like, so yeah, I think there's a lot of interesting work there, maybe of less interest to like programmers, but like if anyone's interested in reading on, the ethics and philosophy of AI, this is really a rich field that's like of extreme relevance right now.
Is there any text or, article, something that is relatively layperson accessible and doesn't have a whole bunch of citations everywhere? Like something that you would recommend to people to get started?
I mean, I can pitch like my employer has a blog. So Human Centered AI Center has a blog. It's called Stanford HAI. That has a pretty good roundup of, a lot of these societal issues. As for a book, I don't think there's specific one that I recommend yet. Like there are a bunch coming out or that have been published recently, but I have not had the time to look at them, unfortunately.
Awesome. Well,
Yeah.
if you're listening to this after publication date and Yifan has reached out to me with a book recommendation, I'm going to include it below. Yifan, we've covered so much ground. It's been an absolute blast talking with you. I feel like we could talk for hours, but I want to respect your time. You're a busy person out there getting things done, researching these models, like not just mindlessly kind of, oh, this is a higher value than this. Like you're actually thinking about the implications of these. It's clear that you are among those who think and feel, and that you do care. You have a big stake in the future of what society is going to be like with these models running around. Do you have any closing thoughts or things that you would encourage listeners to think about?
Especially for freeCodeCamp listeners, I feel like, earlier we were talking about the job displacement thing. I feel like there's this narrative of like, LLMs replacing jobs, replacing programmers in particular. I feel like in terms of like, especially in terms of like freeCodeCamp students, I would say like, even if you want to get into AI, there's always a value in, having good software fundamentals, software engineering fundamentals, programming fundamentals, really understanding like the foundations of AI, which include things like probability and statistics. And I think with those fundamentals, like that will carry you very far, especially because like when I first when I first joined Stanford, when I joined Stanford as a research engineer, and I had to like pick up a lot of knowledge about LLMs, because when I was in school doing my bachelor's and master's, LLMs didn't exist, right? I had to pick up this technology, but because I already had the fundamentals, I could like pick it up fairly quickly and be like, oh, here's, how this new technology relates to the knowledge I already have. So I would say like, honestly, having good software engineering fundamentals, being able to understand problems, being able to work with other people well, these are all skills that are gonna be the most important no matter like what technology comes next.
Yeah, 100%. I really appreciate everything that you've shared here, and I just want to double, triple, quadruple endorse what you just said. When in doubt, go back to the fundamentals, learn them. I like to say that like everybody on Star Trek, like when you see Geordi, working in the engine room and stuff, like they understand the stack. They understand what's going on in the ship and like how all these different systems work. They spent the time to learn it. It's not like, like they're not just grasping the dark. Like education will have progressed dramatically by then. They'll be able to hold a whole lot more facts and understanding models in their mind of how reality works. And they will be able to just imagine. Like I always like to point out, every few years they have to like kind of change the criteria of like the IQ test. Not that I put a lot of stock in IQ tests, but because people just keep getting smarter and smarter and smarter with every generation or every few years. And that's going to accelerate as we have access to more information, as we're like walking around listening to podcasts like this, maybe even at double speed, all day while we're getting things done. And just like our information diet gets more and more enriched, we become, more deep thinkers, and we think on different levels, and we don't just have like our little biases and our misinformation that we carry, but we progress as human beings. And I think as that happens, human society is just going to become more and more competent and more curious. And like this virtue is going to continue to pick up, and we're going to use these tools to continue to extend our own understanding of the world and our own intelligence. And I think that is the profound goodness in the world, is people feeling curiosity, people following it, and not having the intellectual poverty of yore. Like there was a time when it was estimated that like the typical, American out on the frontier living in a log cabin, the amount of information they might encounter in their entire life would be the equivalent of like one day's, Wall Street Journal. And think about all the information you have access to now and all the ways that you can consume it while you're just chilling, you're eating your popcorn, relaxing on the couch, and you're learning about, AI, machine learning, stuff like that, whatever topic you're interested in learning. And so I just encourage you to continue to build out your skills the way Yifan has been working very hard to. We didn't even go into your background, but I'm sure it's exceptional and interesting because you don't get to like Google's machine learning team, or you don't get to Stanford working as a researcher just by accident. I'm sure you worked very hard to get where you are. And at some point I would like to have you back on and we can go more into that. But I just want to leave everybody with the thought of, no matter what happens, fortune favors the prepared, and you can continue to get more and more prepared by building up your fundamental skills precisely as Yifan encouraged you to do so. Thank you so much for coming on the show, man. And with that, I wish you all a fantastic week. Until next week, happy coding.